I mean, that's the reason they make the movies, and they had it translated into other languages so that it could be performed in video, in the theaters in other countries, and the kids could all appreciate it, right? And that was a hit. But here's an interesting thing. They have it translated into different languages for the different countries, but they've also adapted the translations to the culture. So if you're thinking, aha, this is how the United States enculturates all the other cultures in the world to accept our culture and eventually become more like America. It doesn't work that way. Because what Disney realized is the movie would be, in fact it was banned in a lot of countries, even the way they adapted it, right? Because it's kind of hard to get away from the fact that the female characters are the only strong characters in the movie, and the males are all either assholes or dumb, right? Right? They're reindeer herders, or they're princes that are going to rob you blind and kill you if they get the chance, right? Which is, that's just the movie, right? But the sisters are the strong ones, right? And we know that she's singing "Let It Go." She's being herself. She's allowing her, instead of restraining her, so if we do a moral interpretation of the story, right? It's, that the young girls get to be the way they naturally feel, right? And do away with patriarchal, controls and so on and so forth, right? And you think, whoa, that is way modern, Western European culture, right? How's that going to fly in Saudi Arabia? You're not even allowed to drive a car. No, you can. Now you can, a woman can drive a car in Saudi Arabia.
So long as she's supervised.
Maybe.
They have picture IDs?
Do they have picture IDs on their driver's license?
Or driver's license.
Multi-pass. Multi-pass?
No.
Nobody gets...
Leave
Leave. Sorry. Sorry. You don't know multi-pass?
No.
It sounds really familiar.
The Fifth Element was supposed to.
That's such a
Oh.
good movie.
So with a nationwide annuity, you can get projected monthly income for the rest
Oh
of
my
your life.
God.
That's what I'm talking about. How about those song
You
lyrics?
just
What
forced
song
me to
lyrics?
do.
Tell them again. Tell them again. Repeat it. Yeah. Say it again.
So with a nationwide annuity, you can get projected monthly.
Okay.
What the heck?
Last call from Lost in Paradise. Hurry up. ID, please.
Sorry.
There.
Thank you.
Mr. Dallas,
Yeah.
congratulations on winning the contest.
Right, okay.
Sorry for the mess.
The mess?
Garbage.
Hey! I was so afraid I wasn't going to make this flight, so I sent David here to come and pick up my boarding pass. But now David has to go. Thank you. I am boarding pass.
What the heck?
And
I thought I was just going to get right to the person.
Little Dallas Multipass.
Leah at Multipass, she knows Multipass. Leah Dallas, his wife, a newlywed, just met.
Multi-pass. Sorry. It's a cultural thing. You have to have seen that movie or you didn't get the movie. But, all right. So, the interesting thing about all the different languages, if you translate the way Disney translated the language, they changed the song. so that it's culturally correct and the movie can play in the culture without the parents getting upset. Although parents do get upset occasionally. There was a family, a group of parents that were very upset with the French version of it. But I'll show you that later if you're interested. Okay. So, any confused questions so far? Am I driving you crazy? I'm crazy, so that's, it's a requirement for the job, for this job. You have to be crazy. Okay. But we didn't get very far. That's because I tend to demonstrate how crazy I am. But the reason you don't have specific correct answers for test 1 is because it's all up to your interpretation. And I wouldn't say relativity means that there is no truth, but it definitely makes things more complicated when we get right down to it. Okay. But how about, that was arguments and explanations. So truth and logic. Let's take a look at that. That's page 22. Remember to turn this back on again?
You did.
I did? No kidding.
Yeah.
Okay, so there are several different ways that we think of things being true. I showed you the square of opposition, the traditional square of opposition, right? Last class. Anybody remember it?
Is that with the universal, like the AE?
Yes. Yes. Exactly. Right. There's lots of versions of this. We could just pull it up. I don't think this was the one I used before. So there. This is thanks to Aristotle. And basically what we're saying, ever since roughly, 400 BC, or thereabouts, right, is that a true statement is a statement where you're relating two categories, and the relationship that you're stating in those statements match our experience. And then the statement is true. That's pretty easy, right? Although we have a name for this particular theory, and that's the correspondence theory of truth. The correspondence theory of truth argues that a statement corresponds to the actual state of affairs. And then it's true. We do have another theory of truth called the coherence theory of truth. And that gets involved when we talk about especially more compound statements, where we're using our logical operators so that, I think, for example, you're either Bob or you're not Bob, right? Those are, it's either true or false. So it's true that you are Bob, or it's true that you are not Bob, right? But if I put the two of those together and say you are Bob and you are not Bob, then it's a contradiction and it's false. It will always be false, whatever you put in for those two statements, right? As long as you have a conjunction of two contradictions, it's always false. If, on the other hand, I use the disjunct or and say, you are either Bob or you are not Bob, one of those has to be true, and a disjunct means as long as one side of the disjunct is true, the whole thing is true, right? And so that's a tautology. It's always going to be true. If I look at the individual statement, though, you are Bob, that statement is contingent on whether or not you are Bob, right? And so that's a correspondence. So at the level of individual statements, we use the correspondence theory. But once we start making our statements more complex and adding logical operators and or not, if then, those kinds of operators, then we're looking at a coherence theory. It has to be logical. It has to be sound. In other words, if I put it into a computer, it has to run. And the computer doesn't get stuck in a circle or something, right? A loop, right? So those are the two main theories of truth, right? Correspondence and coherence. Yes.
So tautology means a statement that is necessarily true, right?
Yes.
Is that pretty much the same as axiom? Or
No, well, no. A tautology is going to be true no matter what the circumstances in the elements, the single statements that are part of the compound statement. And so if I have a statement like, so I say statement A, and then I say and the negation of statement A, that's going to be a contradiction. Right? If I say A or not A, that's always going to be true. So this form is going to be a tautology. But when you're talking about an axiom, that would be should be a statement like an A statement. 0 is a number, for example, right? 0 is a number is a statement that is contingent on everyone voting that yes, that is true. We all agree that 0 is a number. And if you don't, we're going to shoot you. Right? You know, that's, you know, how they teach math. Right? Okay. So, when we're looking at statements, statements can be true or false. But when we're talking about arguments, now we're talking about whether arguments are valid or invalid. And that's not the same thing as true or false. So a deductive argument is one in which it is claimed that the conclusion follows necessarily from the premises, mean that it's valid. And we'll have examples of that so that you can see how the statement arrangement actually gives us deductive validity, right? An inductive argument, on the other hand, you have lots of premises leading to a conclusion that is only probably true. In fact, because of the arrangement of inductive arguments, they are invalid arguments. Inductive arguments are always invalid. By the way, all science arguments are inductive arguments, which is a problem for science because that means that basic science is not deductively valid. It's inductive and therefore a guess. Inductive reasoning leads to a guess. So for example, there's a swan and it's white, there's a swan and it's white, there's a swan and it's white. We usually say 4 swans, right? And when we conclude, oh, all swans are white. By the way, that's false because there are black swans, right? And not just the ones in the ballet. Right? I don't have any talent in ballet either, so. But that was supposed to be comic relief, right? You know, so there's a reason I do dumb things.
Doesn't science try to be as deductive as it can be, so to speak? I mean, in the sense like hydrogen has no neutrons, therefore hydrogen has the least amount of neutrons.
Okay, you're not essentially doing science though when you're doing that. You're just deductively showing
I mean, those
the,
are the statements.
the conclusions. What? Yeah.
Not arguments.
So what happens is you do science to learn premises And then you put the premises together in deductive arguments. But the science part of it is finding out what's true or false in the world.
As far as like theorizing goes and then testing your hypothesis, kind of.
Theories are an interpretation of the data,
Right.
and they're neither true nor false.
Right.
They're better or worse. Theories are basically stories. I said this data, this data, this data. Okay, my story of what's going on here is also known as my theory, right?
Mhm.
But theories and stories are neither true nor false. They can be better or worse, and that hurts my head. I'm not sure where that goes. How can they be better or worse if it's not the case that one is true and the other one's false? Right? But that's a problem we have. Right? So strictly speaking, science is a collection of evidentiary statements that have been experienced, and then we analyze those experiences and hypothesize that they will always be that way.
I see.
But the trouble is, that you can be wrong.
Right.
So even though I can have lots of premises that all support my hypothesis, one of these days it might turn out that I was wrong and I didn't know about this particular data. Right?
Because we can't look at every single atom in the universe.
Exactly.
Oh,
Exactly.
all right.
Exactly. So it's very frustrating.
Is this different than mathematical induction? Is that different than logical induction, or is that sort of the same?
Well, I would think we're using the word induction the same in even mathematics, although I'm not sure what kind of mathematical
Proofs. It would be
proofs.
Yeah.
Proofs are usually deductive.
Usually.
If we're talking proof, and we'll do the same, we talk about proofs, we're arguing that these are deductive and valid.
Right.
Right? The thing is that you're doing science in order to get the premises. And then you put the premises together, and now you have a deductive argument.
Yeah, science isn't math by any means. Like,
Right.
we had the equations for antimatter before we ever knew it existed.
Math in that sense is, well, it's kind of confusing because the word scientia in Latin means knowledge. And so when the medievals talk about sciences, the queen of the sciences is theology, which a lot of people today wouldn't think of as a science because it's the study of God.
Right. You think of it as
Well,
philosophy.
wait a minute, that's religion, that's not science. Well,
Or philosophy. I mean, Zizek is a theologist, no?
you're allowed to say Zizek in this class. Yes. Yes. How many folks have ever heard of Slavoj Žižek? Žižek? See?
He's great. He's a communist philosopher, and since we're all in America and we don't like communism, he's good to listen to.
It's just one of those things. Yeah.
It's one of those things.
I love his T-shirts too, but that's a whole other thing. What's your T-shirt say?
ATNJP, it's a clown law and order.
Ah.
The YouTuber that I listen to her.
Okay, so we'll do more of deductive and inductive as we go. But the frustrating thing is deductive arguments give you validity. That means certitude. You're absolutely certain. Because if the premises are true, then the conclusion must also be true. That's, happy, yay, we know it's true, right? But your premises are always going to be based on inductive reasoning, which gave them to you in the first place, and inductive reasoning doesn't lead to truth. It's a guess. It's a hypothesis, right? Hypothesis. So basically, when you get right down to it, what this does is tell us we're never going to be sure. Human knowledge is fragile, and we're not certain about things. Now, think about that, though. Does that mean that we have to be all upset because we have all kinds of science devices and things today that are just absolutely incredible? That you can put a spaceship, or whatever you want to call it, on Mars, land it soft enough that it doesn't break, and then the little device comes out and starts driving around and taking 360 pictures and sending them back to us and telling us what the rocks are like and whether there's water there. Okay, that's all built on guesses, but you know what? That's pretty darn impressive, isn't it? Yes? Plus the fact that I'm still alive. I'm almost 68, and I haven't lived the kind of life that should have promised me this long life. I mean, if I knew I was going to live this long, I would have taken better care of myself. But hey, you know, I'm still here. That's kind of impressive. And I'm sure it has to do with the various pills that I take, you know, that increase this and decrease that, and you know, whatever. You know, plus the brandy helps, I'm sure. That's fine. Okay. So, looking at deductive arguments, validity and soundness, page 29. So what's the difference? Just because an argument is valid doesn't mean that the conclusion is true. Because validity has to do with the form of the argument. The argument form is good. So here comes the help that gives us a sound argument. We also know that the premises are true. Well, they're guesses, right? But these are guesses that we all agree on, right? And if that's the case, then we know that the premises are true and the argument is valid, deductive and valid, so therefore the argument is sound. In other words, it's the best human arguments can be. The best human arguments can be. It's a sound argument. Does that mean that some Einstein's going to come along and change it and demonstrate that we were wrong? Could be. Could be. It could be you, actually, right? Okay. So deductive, look at the kind of highlighted comments on the right. Valid deductive argument is an argument in which, assuming the premises are true, it is impossible for the conclusion to be false. Invalid deductive argument is an argument in which, assuming the premises are true, it is possible for the conclusion to be false. So this particular book takes the view that you can have an attempted deductive argument that's not valid. And so, by the way, you'll find there are some logic books that argue that if it's deductive, it's also valid. And so when it's inductive, or rather when it's invalid, and yet it's supposed to have been a deductive argument, the book will say it's not deductive because it's invalid. So that we'll see how that works, but you'll see different logic books taking sides on that. And sound arguments are when it's a deductive argument and the premises are true. Unsound argument is a deductive argument that's unsound when the argument is invalid. Okay. So, talking about form itself, the form of the argument. Got a couple on page 30. All dogs are cats. All cats are snakes. Therefore, all dogs are snakes. You've got a deductive argument of the form. Let's see if I was going to use a sock, but I don't really want to take my sock off. I lied to Colette. So let's see. So all cats. No, let's see. So if I were to draw circles here. And in the middle, I have S. And I'm saying all S are P, and all P is M. You can see that all S would also be M, right?
You want to come make a calculation?
Oh, thanks.
Can I try this? So it sees the
Oh, yeah, that's great, thanks. So this particular argument is a valid argument form, but there's a problem with it, of course. All of the statements are false, right? Because it's not true that dogs are cats, as far as I know, from my experience. It's also false that cats are snakes, right? And it's false that dogs are snakes, right? But the trouble is, if I replace these with other things, the form of the argument stays the same, but I can put in true statements, and since the statements are true, notice the conclusion must also be true, right? So the point that's trying to get across here is that when we're talking about argument forms, the form is either valid or invalid. Same way that statements are either true or false, right? But you don't have statements valid and invalid, and you don't have arguments that are true or false. Get it? Get it? Right? Statements true or false, arguments valid or invalid. What of course we're hoping to do is have true statements, invalid arguments, and then we're happy campers, right? But if we're looking at the form by itself, we can put false statements in there and get very odd results. In fact, this table in the green on the next page is absolutely beautiful because it gives you all the possibilities except for the one that's not possible. That's the one labeled 2 on the left, right? So it's not possible for us to have a true premise and a true premise and a false conclusion if the argument form is valid, right? So if you look through this and read through it and check, it has every single possibility. They are not the same form, notice. The one form on the left is form FA, and the form on the right is form FB, right? But the idea is to show you that you can have valid forms with true premises or false premises. You can have invalid forms with true premises and false premises, and get all these different results. Right? So you could still have an invalid argument and end up with a true conclusion, right? But the value, of course, so think of it this way: if you do your thesis, for your graduate course or whatever, right? And you've done great research, your topic is interesting, but your argument is invalid. So you do all this work, you compile it, you type it, you have everybody proofing it and everything, and then you present it, and then someone raises their hand and says, but your argument's invalid. Your thesis fails. So it's important to have a valid argument. Right? So be familiar with the valid argument forms and make sure that your argument is valid. And then it'll be peachy keen, right? Peachy keen? How do you use peachy keen? Counter examples. If someone gives you an invalid argument, one of the easiest ways to demonstrate that their argument is invalid on the fly, like in a debate, is to give a counter example. So they present an argument. You say such and such, but if I use dogs and cats and use the same argument form that you did, notice you get a false conclusion. So your argument form is invalid. And you've just done that to them. You've destroyed their competitiveness in the debate, right? Because, oh, wow, interesting data, and I like what you say, but it's an invalid argument. I'm not going to listen to someone that gives me invalid arguments unless he's present. Sorry.
I'm sorry.
Oh.
So in saying that, do you mean taking some of the structure that they have, such as all S is P, all P is M, and replacing it with things that would make the statement incorrect?
Well, if what I'm doing is showing that their argument is invalid, it won't work with that one, because that's a valid argument form. So say somebody gave me an argument in a debate. I went back to page 31, right? So how about 7, right? On the right. So right in this green box. So the argument reads, no mammals are cats, no mammals are dogs, therefore no cats are dogs. Okay, so now everyone sitting there listening is absolutely thrilled because he just concluded no cats or dogs, and everybody is sitting there saying, yeah, I agree. But his argument is invalid, right? And so I could construct a counterexample, throw in something else. For example, no whales or fish. Oh, watch me get this screwed up. I'm just making it up, right? So no whales or fish. That's true, right? No whales are ostriches, right? Therefore, no fish are ostriches. Well, that's true.
Yeah, that would be sound.
But it's still an invalid argument. So I didn't do a very good counterexample there. Shoot. I messed up. So close, it felt like it was going to work. So no clowns. No, I don't want to do that. We'll, oh, okay. Maybe we have some counterexamples that they've already figured out how to work. I'm looking at page 33. Oh shoot, what are these? These are totally made up.
Yeah, this section gave me a headache.
Yeah, let's use D. All beagles are mammals. That's true. All dogs are mammals. That's true. All beagles are dogs. Well, shoot, that's true. So that's not a good counterexample either.
What I was getting, the question I had about the use of counterexamples.
E is good.
If you could take something like when you just mentioned the section D of all beagles are mammals, all dogs are mammals, therefore all beagles are dogs. In creating a counter example, would you be taking a logical sequence that works and replacing?
No, I want to make it obvious that the argument form is invalid.
Okay.
So I want something silly. And here's one. This is bottom of page 34.
Okay.
Number E, right?
Mm-hmm.
All men are human beings. That's true. All women are human beings. That's mostly true.
Therefore.
Just kidding. Therefore, all men are women. Well, some people would say that's true. But no, that's false. So here we have a counterexample. So this is an invalid argument. And even though we've got true premises, notice we end up with a false conclusion. And so what you're doing with the counterexample is you're trying to figure out on the fly how to demonstrate that your form is invalid. by using the same argument form, but with statements that are more obviously ridiculous in the situation.
That does that form circumstantially works though, doesn't it? I mean, because essentially we can replace men and women. I'm not having a swap.
No, this is an invalid form.
Okay.
And you have a cheat sheet in the book that you could use to see all the valid forms.
Is that N?
You could. It's in the book, but it's also in the back. If we go to, oops, maybe it's not in the back. No, so let me find. Okay. So page 237. We haven't done this yet, so if you look at page 237, notice you'll have all the syllogisms that are valid under both interpretations. And we'll discuss that when we get to it. Right? So each of these is the name of a syllogism. AAA1 is that one. So that one is a valid form. These are all the valid forms. But you have altogether 256 possible syllogisms. Of that 256, only these are valid under both interpretations that we'll look at. And then they have the others on the next page. So altogether, Aristotle would argue there's 24 valid forms of syllogisms out of 256. And one of the rules that's broken in, say, the one earlier is it has two negative premises. No syllogism that's valid, and I'm looking at page 31 again, where the argument form FB is invalid. It says no dogs are snakes, no dogs are cats. And so therefore no snakes are cats, right? So you have negative premises, it's called exclusive premises. None of those argument forms are valid. So when you look at the rules, the rules help you figure out which forms are valid right away, very quickly, because you can say, okay, so if I have a negative premise, I must have a negative conclusion, but I can only have one negative premise, right? If I have a negative premise, I must have a negative conclusion. If I have a negative conclusion, I must have a negative premise, but only one negative premise. Right? So there are rules that you can pick up to help you very quickly identify which of the 256 valid forms are the valid ones, and you can see those. They also have names. So they all have names. By the way, the letters, remember, are from the AEIO type statements. Right? So when I said, the statement is no, starts out with no, that's an E statement. If it starts out with all, that's an A statement. Some, it's an I statement, or if it's some or not, it's an O statement. So what you're looking at are three statements, all, right, etc. But now the figure we haven't discussed yet, and that's something that we'll do when we're talking about those. But basically, the figure is in the back. If you look at this in the back, the four figures of categorical syllogisms. Those are whatever page this would be. It's not numbered. on this inside, right? 4 figures of categorical syllogisms. Figure 1, figure 2, figure 3, figure 4. It's actually a good idea to memorize those, but they'll be easy, you'll see. So when we're looking at the valid forms, we know it's very mechanical. There's no guesswork when it comes to whether or not the form of a syllogism is valid or not. When we get on to symbolic logic, the same thing applies. We'll have valid forms and we'll have invalid forms, but they'll be more complex. Basically, when you run a computer program, you're running an argument. And if it works, it's a valid argument, right? But it's going to be very complex. I mean, if I went and looked at, well, you know, what you see on this web page is not what the web page actually contains. There's all sorts of crap hidden behind the view, right?
Right.
But it's basically running a logical argument that displays this, right? And if that had been screwed up, it could be all messed up.
Right.
Have the wrong fonts and, you know, screwed up presentation and all sorts of things. Right?
Kind of like your URL is actually just a translation of ones and zeros, but it looks like it makes sense to us.
Absolutely, absolutely. Right?
A lot better than typing 0100010.
A lot less boring and a lot easier for us to figure out. Yes.
Okay.
Lots of. There are some things computers are much better at doing than we are. Lots of data, figuring out the argument very quickly and so on. But famously, of course, the computer that beat, you know, I forget who the chess player was. Yeah,
Blue something?
yeah, something blue. You know, beat the chess player. You know, but the thing is that the computer didn't even know it was playing chess. Right. You know, so there are things that humans are really very good at, and that's doing analogies. We're really good at analogies. Like your drink looks like applesauce to me from here. But I know it isn't applesauce because you can't drink applesauce with a straw.
Yes, you can.
Yeah, you can.
You so can. Haven't you ever had your wisdom teeth out?
Yeah.
I've had all of them out, that's why I'm so dumb. No, I'm just You can suck applesauce with a straw. No,
Yeah.
I don't want to go there.
Your mind is blown.
Yes, yes.
Yogurt
Is it
might be
applesauce?
difficult.
No,
Yogurt.
it's iced coffee.
I've broken my jaw twice, man. You'd be amazed at things that you can eat from a straw.
Okay, sorry about that. Didn't mean to bring up all those things. But I just made an analogy comparing from what I see, it looked almost like applesauce. I bet that was orange juice. It probably was, but it didn't work because it didn't have enough caffeine for the person that drank it. But that's okay. However, but what am I doing when I'm recognizing those? I'm making analogies. Computers would not be able to know, would it? We could program them, I suppose. Like we can program them to recognize faces, unless you're in California, where it's now illegal to do that. Personally, I like the idea of Facebook telling me who's in the picture. I think that's great. Especially when it's a person coming up and stealing from your house, you know, and everyone says, oh, I know who that is, and Facebook says, yes, that's George Papadopoulos, or whatever, right? And then you can call the police and say, George Papadopoulos just stole my kid's bicycle, right? I think that's great.
If it's accurate.
Pardon?
If it's accurate.
Yeah.
True. Well, but of course that's an issue, you know. And if George actually wasn't that person, then he could probably say, well, I had my alibi. I was stealing a bike over in that yard. And then I know. Oh, I'm sorry, George. Got the wrong George. Should we take a break? Some of us need a break. I'm not going to go downstairs and run this though.